Hello everyone. Today we'll see a simple topic, that is plane of symmetry and center of symmetry. So this is a part of stereochemistry from PU second year. So what is plane of symmetry? Plane of symmetry is anything that cuts. Plane of symmetry is a line which cuts a molecule into two equal halves. Plane of symmetry. For example, I'll take an example here. I have an ethene here. So this is ethene, has got this structure. If I cut the molecule ethene into from here, from this line, I'll get this part and this part. Part 1 and part 2 are mirror images of each other. So this is the line through which I can cut a molecule into two equal halves. Therefore this is called as plane of symmetry. अगर plane of symmetry है कोई molecule के अंदर, even though having chiral center है उसके पास, फिर भी ये optically inactive हो जाएगा. Right. Next we'll see the center of symmetry. Center of symmetry के लिए let us take the benzene here. Benzene I have taken here. If you start from the center of the molecule and you travel in opposite direction, if you end same groups on both the ends, so we call it as center of symmetry. If I move from here to here, even if I move from here to here, even if I move from here to here, I'll get the same parts, same groups on either sides. So this is what we call it as center of symmetry. If any one of this is present, that molecule becomes optically inactive. It becomes optically inactive. Let us see few examples here. I have taken benzene. Benzene, you can cut it to two equal halves in this direction. You can cut in this direction, or in this line, or in this line, or in this line. So you will get plane of symmetry is present. That's why it's optically inactive. We have got 1,4-dimethyl benzene. Even dimethyl benzene can also be cut through this lane. So when you cut this, you will get first part and second part. Both of them are optically, they are mirror images of each other. Even though here, so we have got the same kind of plane of symmetry is present here, right? So in both the cases we don't have any chiral center, but they don't have the plane of symmetry. Let's say we have taken 1, 2, 3. 1,3-dibromocyclobutane I have taken. So this is the chiral center. This is also chiral center. But if we cut the molecule into t equal halves, let's say here, if I cut from here, so this bromine is above the plane, this bromine is the below the plane. This is not the plane of symmetry. If I cut from here also, I'll get the same thing. But if I start from here and move towards this bromine and I come opposite to the same direction, I'll end up with the same groups even in the other direction. So this molecule has got center of symmetry. Due to center of symmetry, it becomes optically inactive due to presence of these optical active chiral centers. So same example is also given with another group here. This molecule has got center of symmetry even on both the directions. Due to presence of center of symmetry, this molecule is also optically inactive. Let us see one question on basis of same concept. Here is the question which is previously asked in many exams. IIT Advanced में, JEE Mains में भी पूछा है, NEET में भी पूछा है. The question is, which of the following structure is chiral? Molecules have got chiral centers on all the ways. All four carbons are optically, all four carbons in every molecule have got a chiral center. But we have to check whether do they have any POS or whether center of symmetry. इनमें से which of them is present in them, we have to check. Let's go with the option 1 here. If I cut this molecule along this line, so this is the first part where bromine is above the plane. This is the second part where bromine is the above the plane. In both the cases, we are getting two equal halves, so it has got the plane of symmetry. So although it has four chiral centers, due to presence of plane of symmetry, it is optically inactive. Now let's see the option number 2 here. Even in the option number 2, we don't have any plane of symmetry, because if we cut from here, this bromine is lying above the line, above the plane. This is below the plane. If I cut from here, chlorines are in opposite planes, so it has no plane of symmetry. But if I start from here, and I'll go towards this bromine, and I come opposite to the same bromine, I'll end up with the same groups on both the sides. So these groups are equivalent. So this shows presence of center of symmetry. Even if you go here and come here, you got the same groups on both the sides. So option 2 has got center of symmetry, due to which it is also inactive. Let us see the option number 4. In option number 4, let us say if I cut in this plane, right? So this is the first part, this is the second part. First part, second part are mirror images of each other. This bromine, both are above the planes. Both the chlorines are below the planes. Perfectly, they are mirror images of each other. Due to presence of POS, this molecule is optically inactive and it doesn't have any chiral structure. But when you check the option number 4, in option 4, if you cut, you don't get any plane of symmetry. If you cut here, you don't get any plane of symmetry. ऐसा भी करो, there is no plane of symmetry. All of them are the different. Let us try the center of symmetry. So this we don't have similar groups. Here also we don't have the similar groups. So in option 4, POS is missing out. Even COS is also missing out. All 4 chiral centers are possible. So due to these 4 chiral centers, it is optically active, and answer for this question is optically active. Option number 4 is the right answer. Thank you.